Okay, for the Dom. This, I put them in different colors because an if-then statement. An if-then statement says if you have the first requirement, then you can have the second. So what goes in the blank here? Who can tell me? Yes, sir. Very good. If the lines are parallel, then the corresponding angles are congruent. Now, that's what we did on Friday, which seems like 80 years ago, I know. That's what we did. Every one of our postulates and theorems started with if the lines are parallel. In fact, you want to get out your postulates and theorems section because you're about to be adding things to that. And I'm going to ask you to take a moment to look at those postulates and theorems and note, Jensen, you're not in your seat, that all of those start with if the lines are parallel. If the lines are parallel. Actually, you guys gonna talk a lot if I leave you there? I will not talk. Ever. Caitlin, would you like to move? No, you don't want to move? Fine, forward. Do you want to move? You go. You have to move to his seat. You have to move to his seat. All right. Does everybody have those postulates and theorems out? They should all start if the lines are parallel. Why is he hammering this? Because today we're doing the exact same thing, except it's going to be flipped. They're not going to say if the lines are parallel. Today we need to be proving that lines are parallel. And we're going to do that using the converses of what we did Thursday, which says today's are going to say if the corresponding angles are congruent, then the lines are parallel. That is an important distinction if you're going to get your proofs right. And we are going to start looking at a proof today. Okay. 3.3, prove lines are parallel. The postulates and theorems, not this exact line, but first one, postulate 16, corresponding angles converse. They're all going to be called converses because they're going to be the exact same thing you worked on Thursday, but in a very important different order. If the angles are congruent, then the lines are parallel. Big difference today. You may think that's a minor thing, but mixing up those two concepts could cost you points on test. It's all about which one did you know first and which one are you showing. And here's a hint. Anytime you are showing the lines are parallel, it's going to be a converse. If you want to make a note of that somewhere, if you need to show they're parallel, you're going to be using one of your converses. So if you want to note that somewhere, it'll probably be helpful. I'll just keep flipping through the slides. They all pretty much say the same thing. The other day, alternate interior angles theorem said if the lines are parallel, then you know the angles are congruent. Today it's going to say if the alternate interior angles are congruent, then the lines are parallel. We done with this slide? I am going to be going through, we have several of these to write down. This is 3.3 in your book. So if you're someone who tends to write a tad slower, you might want to just open up your book to 3.3 and go from there. I believe it's on page 162, I think. Okay, there's the next one. Again, if you didn't get finished, page 162 in your book has them. I think it's 162. Alternate interior angles converse. And there's the alternate exterior angles converse. Alternate exterior angles. Actually, this is literally the exact same thing as the last one. If you want to put like something that says, hey, it's the same thing. Only thing different is the word interior and exterior. Then that could save you some time. If you want to write the exact same thing as before, except exterior not interior, might save you some time. They're both congruent. Alright. And the next one, we only have two more. The consecutive interior angles converse. If the angles are consecutive and congruent, then the supplementary, not congruent. Then the lines are parallel. Now remember, you can use your handwritten notes on the test, so I'd be encouraging you to add these in there. Because there is going to be a section in your next test that says, what is the theorem? What is the postulate? You don't even know. In fact, there'll probably be multiple choice. And I'll tell you right now, on every one of these, two of your options. One's going to be the converse, one's going to be the original. You're going to have to pick correctly. I'm so glad you guys laughed at that kind of stuff. My wife hates my movies. We watched a British show yesterday, and then she got mad at me using a British accent. I mean, don't the two things go together? How can you watch a British show without using a British accent? You really are tired today. Yeah. You're laughing at everything. Hey, I'll take it. It's good for my ego. What? So it is? Yeah. Your women don't like to use what you do? No. Alright, I'm skipping ahead. The last one is completely different than this. Ooh, one of the things we haven't covered yet, but we need to go back and cover that we skipped in chapter 2. Who here watches The Big Bang Theory? Oh, awesome. Who watched the most recent one? The one where the girls read the comic book? Did you? Okay. You remember the part at the end where Bernadette says, by the transitive property of picking things up, if Thor picked up the hammer and someone picked up Thor, are they picking up the hammer? Remember saying that? Awesome. You guys, only one of you remember that. I thought about that because that kind of goes with today. The transitive property states that, here's essentially what it says. Let's say Malik and I are the exact same height. Okay? It says, if I'm the same height as Malik, and Malik is the same height as Salvador, then I am the same height as Salvador. That's what the transitive property says. If A equals B, and B equals C, doesn't matter. Then A equals C. Okay? Well, that goes along with this last theorem. If two lines are both parallel to the same line, then they are, by this transitive property, parallel to each other. If Gibson's favorite player is Kobe, and Brandon's favorite player is Kobe, I don't know I'm going to the Jordan player. Okay then, there you go. So that can kind of work. Transitive property. If P is parallel to Q and R is parallel to Q, then they are parallel to each other. That's the entire transitive property in a nutshell, but I'll be going back and teaching you The actual transitive property, as you probably learned before, is that if 1 plus 3 equals 4, and 2 plus 2 equals 4, then 1 plus 3 equals 2 plus 2. That's the mathematical transitive property. You can set two things equal if they equal the same thing. But this is how we're going to use it today. Questions on this one? And click. Okay. Here we go. Find the value of x that makes j parallel to k. What kind of angles are those? Thank you. Well, what is the vocabulary? Corresponding, that's right. Now, if these lines are to be parallel, then that means their corresponding angles have to be what with each other? Congruent. And things that are congruent, we do what with each other? Yes! Set them equal. Here we go, math time. 53, oh, not plus, equals 7x plus 4. Exactly. Muy bien. Just. There you go. 7. Questions. See, the math is the exact same thing we did Friday. The only thing different is the way we're approaching it. Other questions on this particular problem? Click. Find the value of x that makes L parallel to M. Someone other than Blake. Tell me what the angles are, and don't say congruent. What kind of angles are they? Someone other than Trip, too, because I know Trip's going to fire out an answer, because he's always all over this stuff. Brandon, what kind of angles are these? Yes, sir. And you were in the office. Not that that had anything to do with this. I'm going to make it seem like if he knows it, then everybody should know it, but very good. I don't know why that's the case. You missed a few days last week. There you go. And he still knows it. These angles are corresponding. Therefore, if the lines are going to be congruent, the angles should be what with each other? Congruent. And if angles are congruent, then therefore we should set them equal. Divide. Thank you. I moved too slow. Questions. It doesn't ask us to plug it back in. It says find the value of x, so that's what we did. The first and most important step. Figure out what kind of angles they are. Then, beep, 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 beep. Look at your theorems, and it'll say congruent or supplementary. Of course, you could always just look at them too. Now, in a second, it's going to be asking you to start naming the theorems. You're going to need to name stuff from today. Is there enough information in the diagram to positively conclude that the two lines are parallel? Don't just say yes or no. If yes, tell me what theorem we would use. Elijah, what kind of angles are those? Do we have a piece of vocabulary for those angles? Shh. You're exactly right. You started to say alternating and you stopped. Why did you stop? They are exterior, but they're not alternating, right? You're absolutely right about that. So you were right to stop yourself. So you may be thinking, nope, we don't have a theorem for that. But can we use logic at this point? What's another angle? Just by knowing the 70, describe to me another angle I can figure out in this picture. Let Trip. Here? Yeah, we'll just do it here. How would I, first of all, how do I know that this is 110? What's the vocab word I'm looking for? Linear pair. They're a linear pair. Now, what kind of, Elijah, I'm coming back to you. What kind of angles are these? They are alternate exterior. Very good. Now, very good. Look at your theorem. Alternate exterior angles should be supplementary or congruent. Did you just write down your theorem? Look, the alternate exterior angles converse and say, does it say the word congruent or supplementary? You've got to be able to look at those theorems and find that key word. They are supposed to be congruent. Are they congruent? Yes. So, explain. Here's how you would need to explain these today. Step 1, we use the linear pair postulate, which I realize I've never actually, we'll go over that maybe in a day or two. And step 2, we use the alternate exterior angles converse. Or you could give me the number. I don't remember what number it was. I guess that'd be what? 3.5? I don't remember. Was it really? Hot diggity, it's my day. Alternate, but I like to use acronyms. That way I remember what they are. The alternate exterior angles converse says that if alternate exterior angles are congruent, then the lines are parallel. Here we go. Okay. Find the value of x that makes A parallel to B. Or not to B. Okay. Caitlin, what kind of angles are G's? It's alright, you can look through your notes and your vocab. What kind of angles? They are consecutive interior. Elijah, I'm going to keep coming back to you until you do this. Look at your consecutive interior angles converse in your notes and say, which word is there? Congruent or supplementary? Nobody better say it. Consecutive interior angles converse. Consecutive interior. What's the key word? Supplementary. And what do you do with things that are supplementary? Add them to 180. 62 plus 5x minus 2 equals 180. 62 minus 2 is 60 plus 5x equals 180. What do I do now? Subtract the 60. What does that give me? Then what do I do? 5 by 5. Cool beans. Y'all did it. Now, there's multiple things you can do. There are multiple ways to figure out what y is, but I will take someone suggesting it. What's one way we can figure out y? Seriously, quit flipping that thing. Who can tell me how to solve for y? That doesn't plug what in? And for x, then what do we do? Well, let's go ahead and do that. If it's going to be that, that's going to be 5 times 124 is 120 minus 2 is 118. What do we do with that? Well, we already know what that's going to add. What did you say? How do you do that? How can we solve for y? I'll give you a hand. I'm looking for pieces of vocab here, like a converse or a postulate. That's one thing we could do. That is one thing we could do. You could do vertical angles and then do the consecutive interior angles converse. Or you could do linear pair and do, of course, consecutive interior angles. Or you could do linear pair here and do alternate interior angles. Or you could do alternate exterior angles and do vertical angles. I mean, there's so many things you can do here. So, all right, which one is that? With which angle? The 118 or the 62? 118. So you want to find this angle. Now, vertical angles are what with each other? Congruent. So we use the vertical angles theorem. Now, what can I do with these two? Nobody say it out loud. I'm going to pick someone in a second. When Jasmine. in your theorems, what kind of angles are these? What kind of angles are they? What? Yes, but are they consecutive or alternate? Are they on the same side of that line or the different side? So they are consecutive. In the consecutive interior angles converse, what's the key word? Supplementary. And what do we do with things that are supplementary? Them to... Jeez, I believe I'm talking to somebody else. Ooh. I'm not really angry, but respect their answers. Alright, so subtract, divide, and y equals 8. There you go. We did it. We did it. Questions? Do not think that there's only one right way to do some of these problems. If you did it one way and somebody else does it a different way, that doesn't mean you're wrong. That just means they're different. Click. Ooh, 3 of them. We're just going to talk about. I trust at this point that you guys know how to solve. We're going to talk about how to set them up. And if you can answer my questions, then I'll be feeling good. Hold it. Oh no. Hold on. Oh shoot. Yeah, it is. I found it. It's okay. Alright. Let's see. Who's he going to pick on? I'm moving it. Hold on yet. Miss Doherty. You knew it. What kind of angles are these? Just tell me what kind they are by vocab. What was it? That's okay. We've got 40 minutes. 2,400 seconds at your disposal. Because I used to work at a bookstore and I get really bored. So what I would do is I would just calculate the seconds until we left, and I'd walk around depressing people. They'd be like, "Oh, 2 hours." Like, only 7,200 seconds. They'd be like, "Oh." That's a true story. That's what made my wife fall in love with me. Story, man. What was it? Trip, she's tagging you in. I mean, not Trip, Drew. She's tagging you in. What kind of angles are these? Alternate exterior. Becca, alternate exterior angles are what with each other? Yes, I wish you had said that more clearly. Yeah. Congruent. Very, very good. And what do we do with two things that are congruent? Set them equal. That's how we'll solve this. Moving on. Who's he going to call on next? Who knows? Who's he going to call on next? Who's he going to call on? Hey, that's not a rule. Elon! What kind of angles are these?
Those are alternate interior angles.
Alternate interior, Donovan. What are alternate interior or what with each other? They are congruent, so set them equal. Uno mas. Sage! Not getting off. What kind of angles are these? I will give you the consecutive. There you go. And Rachel. Consecutive interior angles are what with each other? Supplementary. So instead of setting them equal, we actually add them to 180. Very good. Okay. Okay. This one, all you're asked to do on these are straight from your homework, but I wanted to discuss them real quick. We'll discuss the odd ones. What you have to do is determine if you have enough information to show that the lines are parallel. Now I'm gonna do the odd ones for you. You're welcome to write down what I say, or you don't have to. You're gonna have to do the even ones. Well, actually, that's not true. I asked you to do all of these in your homework, so it actually benefits you to say write down what I say. And I'm gonna give you 3 answers. Number 11. Do you have enough information to conclude that those are congruent? What you are looking for is does it give you the angles that match one of your theorems? Look at those 2 angles. Do you have vocab for those specific angles? What are they? Now, what do these 2 lines represent? What does that mean? That means they are congruent. Yeah, say number of loops. Do your notes say that if alternate exterior angles are congruent, the lines are parallel? And which theorem is that? Yeah, if you want to give me the name, that's fine. I think that's what we said earlier, 3.5. So this is how you'd answer this. You'd say yes, comma, and you can either write alternate exterior angles converse or theorem 3.5. That's how you will answer that. Yes, by the alternate exterior angles converse, or 3.5, whichever one you decide. Number 13. What kind of angles are those? They are corresponding. And this implies that they are what with each other? Does your corresponding angles converse state that corresponding angles are congruent, therefore lines are parallel? Yes. So this one would be yes by postulate 16 or your corresponding angles converse, whichever one you choose. I like acronyms, CAC. That's just me. Last one. Ooh, looks like they're giving us too many information. But who knows what the definition of white noise is? White noise. It's an expression that people say. They'll say, "Oh, that's just white noise." What that means is that's something. You ever been like at a basketball game and somebody's shooting a free throw and everybody's just going crazy to try to get them to? That's white noise. They're trying to give you something to distract you. What in this picture is a complete and utter distraction that you don't need? Line R. Completely unnecessary. Cover that up. What kind of angles are those? Alternate exterior. Do we have a theorem that says they should be congruent? So that would be yes by the alternate exterior angles converse. I will tell you this. Of the 3 you're going to have to do, 2 of them are no. And if it is a no, then you don't have to explain it. You can just put no. 2 of those are a no. 1 of them is a yes. It's up to you to look at these 3. Now, some of you might be thinking, but wait, those are vertical angles. Those are a linear pair, blah, blah, blah. When you are showing the lines are parallel, you have to use one of the things we did today. You can't use some of the stuff we've been talking about to figure things out. You have to use one of your converses. If you do not have a specific converse, then you can't prove these lines are parallel. So that should help you. 2 of those are no. 1 of them is yes. It's up to you to figure out which is which. Okay. Last thing. Dun, 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 dun. Proofs. We're entering into them. These will be worth a considerable amount of extra credit if you get them correct on a test. Now, here's what a proof looks like. They're going to give you 1 fact every time. Given. Well, not 1. Sometimes they give you more. Given. And then they ask you to prove something. In this picture, they gave us these. Now, please notice, this is proving the alternate. Remember in the past when I said there's a difference between postulate and theorem? A postulate is something, it's a fact, I'm giving it to you, done. A theorem is something you have to prove in order to use. So we're proving the alternate exterior angles converse. That's why you can't just use. Because some of you are like, yeah, duh, if 4 is congruent 5, alternate exterior angles converse, and you're right. But we're proving that, so you can't use that. But you can, however, use postulate 16. You might want to glance at that. So, who can tell me, just by looking at the picture, what is something else we know? What is something else we could figure out? by looking at this picture. I'll give you a hint. It labels the other angle you're going to need to know. Stacey, what do you think? How? Yeah, angle 1, you're right. What's something we could conclude about angle 1, and how could we conclude that? It's vertical angles, and therefore, vertical angles are what with each other? They're congruent, which means these two are now congruent, right? Right. So, what kind of angles are these? That's right. And then, if they're corresponding, how could you, if they're congruent in this theorem, in the proof? What have we been doing all day today? If these are congruent, then the lines are parallel. Which postulate is that verbatim? Right. Here's how these proofs are going to look. You have to list exactly how you know things. Step 1, we knew what was given to us. We knew that angle 4 was equal congruent to angle 5, and that was given. Step 2, the vertical angles theorem, which Stacey said. 4 is congruent to 1. Yay. Now, have we at any point, we're showing these two are congruent, right? Have we stated that anywhere over here that 1 is congruent to 5? No. Now, there's something we talked about earlier. We only talked about it. I had a conversation with Caitlin about it. It was the blank property that stated if two things are congruent to the same thing, they're congruent to each other. Who remembers what that was? It was a T word. Yes, sir. Yeah. Well, actually, it's just transitive property for right now. You're right. The transitive property states if two things are congruent to the same thing, they're congruent to each other, then once you know that 5 is congruent to 1, we can finish this thing up with the corresponding angles postulate, which states, or excuse me, converse, corresponding angles converse, that states if you have two lines cut by transversal and their corresponding angles are congruent, which you've already shown, then the lines are parallel. We're going to do maybe 1 or 2 of these every day, and then maybe by your next test, you'll have enough to do one on your own. Okay. Here's one thing. 1 point, just list your givens every stinking time. That's the first step to any proof. So a lot of people get 1 or 2 bonus points on a test just because they do that one step. First step to every proof is to list your givens as your first piece of evidence. Okay, here's your homework. Don't worry, there are no proofs in it. There you go. Good lesson.